Welcome to qnawire.
What we have is a problem regarding conservation of momentum. We're told that in a backyard game of bocce, the 32 grams palino or jackball was thrown first, came to rest in a clump of grass in an elevated position, and then the 422-gram red ball was thrown next with a backspin and at the first bounce struck the palino with their centers of mass and exactly the same level. Immediately before the collision, the red ball had a certain velocity and no spin because it had bounced off the lawn, and we want to use this information in order to know what would be the new velocity of the red ball, considering that the velocity of the palino ball after the collision was 0.320. So essentially what needs to happen is that the change of momentum for the system needs to be equal to 0. So that means that the final momentum minus initial momentum needs to be equal to 0. In this case, we can separate the final momentum in final momentum for the red ball plus final momentum of the palino ball minus initial momentum red ball minus initial momentum of the palino ball. The information that we had regarding the velocities is that the initial velocity for the palino ball, that is going to be immediately before the collision, is going to be equal to 0. It is at rest on a clump of grass. And the initial position for the red ball is going to be equal to 0.326 meters per second. The final velocity for the palino ball is going to be equal to 0.329 meters per second. And the final velocity for the red ball is going to be R unknown. We're given the values for the masses, 32 grams and 422 grams, and with this we can solve the problem. So the final momentum for the red ball is going to be mass red times final velocity of red plus final momentum of the palino ball, mass of the palino ball times final velocity palino ball minus initial momentum, mass of the red ball times initial velocity of the red ball minus mass of the palino ball times the initial velocity of the palino ball. Let's cancel things that are equal to 0. Since this velocity is equal to 0, we're going to get 0 over here, and the rest of the values we can solve for. The sum of all of this needs to be equal to 0, and we can get the value for final velocity of r. It is going to be that mass of red, final velocity of the red ball, is going to be equal to mass of red, initial velocity of red, minus mass of the palino ball times the final velocity of the palino ball. In this case, we don't need to transform the units of the masses into anything else because everything is on the same unit. Everything is going to be in grams, so we're going to be able to divide the results directly without having to worry about that. So the final velocity for red, we simply can pass the mass divided into the left hand side. So over here, over mass of red. So this final velocity is going to be equal to mass of red was 422 grams times the initial velocity for red, 0.326 meters per second, minus the mass of the palino ball that was 32 grams times the final velocity of the palino ball, 0.329 meters per second. Notice that everything here is going to be in the east direction, so the final velocity is going to be as well on the east direction. And all of this we're going to divide it by the mass of the red ball, which is 422 grams. So the final velocity for red is equal to 0.301 meters per second. Notice that the units over here, grams and grams, are going to cancel out with grams, respectively, and we're going to end up with meters per second. So this is going to be our final answer. Thank you very much, and have a good one.